This is kind of a tricky problem because it hinges on certain tricks that deal with triangles. Before we even look at the answer choices, just reading the problem that we have, it's a rectangle with side panel AE, or rectangle with side AE. It's the roof, and then we have a solar panel, which is this AB and CD, because the panel is just kind of moving. How much longer is DE than BE? So we're looking for basically this distance right here. We just have to basically get the height, the two heights of these two respective triangles, and from there we will have the difference, and that's the answer. The trick here comes from the fact that this is always a right angle right here. And since we know that this is a 45-degree angle and this is a 90-degree angle, the other angle formed for this triangle must be 45. Likewise, since this is 90 and this is 60, this here must be a 30-degree angle. So we now can deal with the special properties of right triangles, namely that when you have a 45, 90 triangle or a 30, 60, 90 triangle, the ratios of the sides are already established. X, and x times the square root of 2 in the case of the 45, 90, and x times the square root of 3 and 2x for the 30, 60, 90. Those are ratios that are totally worth memorizing on the GMAT. You want to be able to just whip those out whenever you need to. They are critical to solving some geometry problems very, very quickly. This is a classic example of one that you can solve very, very quickly. It's not going to go as quickly because I have to talk you through it, but if you were doing this on your own, this would be done almost instantly. So if you find any one of the sides, any one of the three sides of one of these special right triangles, you can then solve for the rest. The other thing that helps here, since we have to try and find the heights of each of the two triangles, they have the same hypotenuse. So the side opposite the 90-degree angle here, x, this one is equal to this one. And from there we can find all of the sides of the triangle. So if we get even one single value for any one of the sides, we have all of them in here. So let's look at the statements. Statement 1, CD, and where's CD? CD is 24 meters long. So CD is that hypotenuse. This gives us, so CD equals AB. Each of them is 24. And so we would say 24 here and 24 here, and we need then the sides opposite the 30-degree angle. In this case it would be 12, and this would be 24 over the square root of 2. Whatever that comes out to be. It comes out to be 12 times the square root of 2, actually. Anyway, so you would subtract those two, but that's way more math than you actually needed to do. All you needed to do is see, hey, we got one side, we have everything. Statement 1 is sufficient. Statement 2, so we can cross off B, C, and E. Statement 2, BE is 12 meters. So this is 12. This gives us the side opposite the 30-degree angle in the 30, 60, 90 triangle. So this gives us the 12 here. From there we could figure out the 24. We would plug in the 24 here, and we would come up with the same answer and solve the rest of the way again. So again, knowing that once you have this framework you can figure out anything, just recognizing that each one of these is one of your numbers, you're done. So either statement on its own is sufficient.